As we have discussed earlier, that star to delta transformation and delta to star transformation are mainly helpful to make the circuit simpler so that we can uh, easily solve the circuit and its desired parameters. Okay, so as you can see in the circuit, let us first focus on the first this circuit. For example, this is the circuit in which this is given. So also it is necessary that we identify the star or delta from the nodes given or from the mesh which is given. Okay, so if we see in this diagram, we can see that this is one node, this is one node, this is one node. Okay, so and they are having a enclosed figure. Okay, so it is immaterial whether they are in straight line or not, but we should be in position to identify which symmetry it is forming. Okay, because for example, if you label this as A and this as B and this node as C, okay, so it is nothing but it can be considered as this B node is as it is. Okay, so I have just pulled this C node above and this A node above. So now its shape is similar to what we have learned earlier. Okay, so now you can say, okay, this is delta. But when these are placed in the straight line, you get confused that whether it is delta or not. But things remain same because here also the resistance between the A and C is R1. Now in this diagram, revised diagram also it is R1. Okay. Here this A and B is having the resistance R2. So it is also R2. Again B and C it is R3. So it is R3. It is just that we have to identify and capture that whether these nodes are forming the star or delta. Okay. Now since we have identified that it is a delta, now we can convert it into star. Okay, using the formulas which we have already studied. Okay, so the formulas which we have studied gives us the formula Ra equal to R1 R2 upon R1 plus R2 plus R3. Okay, so if the values of R1 R2 R3 are given, then we can easily calculate the values of Ra, Rb and Rc. Okay, so this is the star transformation. Again, you might say that it is not looking like a star, isn't it? But it is just your perception to identify that this is this star, because in the last class what we have studied that during this star how can we identify that it is a star, that there is a common node and different branches are connected to this common node, then you can say that this is the star. Okay, so here also when we have converted this, you can say ABC delta into star, what we are getting same thing, but representation may be different from what you have seen earlier. Okay, so for example, in this figure, if you pull this resistance here instead of here, and it is connected to here, then it's good enough. And similarly, if it is not here and it is connected to here, now you might say, okay, okay, good, this is RA, I have identified, this is RB, this is RC, we have identified it. Okay, because now you can see the shape of star. Okay, it is same as earlier. In earlier diagram also, this common node was connected to this resistance and this battery source in a series. Now also it is connected with this resistance, and this resistance are in series and connected with the battery source. Okay, so it is just the matter of perception. Okay, so since now it is converted into star, we can easily calculate RA, RB, and RC if R1, R2, R3 are given. Okay, similarly, if the in the forthcoming numericals, if the numerical is complicated, these battery values are also given, and we are required to fall to calculate the you say currents or drops or power consumed, as we have discussed in previous numericals. We can do that as well, because again, if we see these see this circuit minutely, now since this is a revised circuit, you can also say, okay, this is say resistance 1, this is 2, this is 3. So say this is the battery source 10, 20, 30, and so on. Okay, so now you can say that this circuit is redrawn as this 1 ohm, and 1 ohm plus RA you have seen R by 3. Say, let us suppose that R is equal to 3. This small resistance R is 3. So this RA also becomes 1, because 3 upon 3 is 1. Okay. So we can redraw this circuit. There's 1 ohm and 1 ohm as 2 ohm. Okay. So it can be drawn as a 2 ohm in series with the battery source. This battery source can again be drawn in such a manner so that it is more comfortable to you. Okay. So this is now 2 ohms. Now next is the RB. RB is R. So R was given as 3 ohm. So these 3 ohm is in series with 2 ohm. So it becomes 5 ohms. So you can draw this as 5 ohm. Okay. I will draw the battery source later. First, let's resolve these resistances. Okay. Similarly, if this RC RC is calculated and it is having say value of 6 ohm, then 6 and 3 becomes 9 ohms. Okay, so we can draw this as 9 ohms. Now you can draw the you can apply the KCL KVL. Okay, to get the better feel of it. Okay, so again, what you have to do, you have to check the polarities of the battery sources. We have seen that this battery source and these battery source are in series. Okay, so they will be added up, and these two are also in series, so they will again get add up. Okay, so we can solve this way. Okay, so now we will take another example of star to delta transformation. So if this circuit is given like this, okay, now this internal triangle is given and external triangle is given. So this, so internal, it is star is given. So this star can be resolved into a delta as shown in this dotted line. Okay. So when we have converted that internal star into delta using the formulas above, this is the resolved diagram which we will get. Okay. So in this resolved diagram, we can say that these two resistances are in parallel because in this node there is a current division. Similarly, the two resistance which are here will be in parallel, and similarly the third resistance, this resistance and the resistance which is transformed into delta will be in parallel. Okay, so this is the parallel arrangement shown here. So we will do the calculation, parallel calculation, parallel calculation, so that this circuit becomes simpler. Now this resistance and this resistance becomes in series. So our circuit is resolved into a simple Ohm's law type of circuit. Okay. So in this manner, we can solve this star to delta and delta to star effectively. Okay. So let's begin with one of this numerical. So in this numerical, we have to find the resistance between the AB of the circuit using star to delta transformation. Okay, so now you can see that A node is given and CD is given. So effectively, if you can see that this A node, if we can write here or here, it is all the same because there is no resistance in between. Okay, so now you can see that this is a ACD. Now this ACD is having the shape of a triangle or delta. Okay, so you can see that we can resolve this delta ACD into a star ACD. Okay, so in this fashion we have converted into a star. For your convenience, I have marked this resistance as R1 and this R2 and this R3, just so that the numerical is clear to you. Okay, otherwise it will not be given. It is your assumption. You can assume whichever resistance as R1 and whichever resistance as R2, R3. Okay, just because we are doing this first numerical, so that things are easy at your end, I am doing this. So when we have calculated the star resistance Ra, its formula was R1 R2 upon R1 plus R2 plus R3. Remember that equation number 5, 6 and 7 which I have explained earlier in the previous class. So I have given here R1, R2, which is nothing but R1 is RAC. Okay. RAC is, just a minute, RAC is R2 and RAD is R1. Okay, this is R1. So if A is here, so AD is this. Okay. So this is RAC upon RAD. Just for your convenience, I have written RAC, RAD and in bracket R1, R2. But in actual practice, it is RAC and RAD only. It is not that these two are multiplied. Okay, it is just for your sake. And in the denominator R1 plus R2 plus R3, in actual it is RAC plus RCD plus RAD. So we are calculating this and we will get the value of RA as 2 ohms. Okay. Similarly, we can calculate the value of RC and RD. Denominator remains same 12 ohms, and in above other two resistances are taken at a time, and we will get the value of RA, RC and RD as shown in the diagram. Okay. So now what we are going to do, we will place this RAC, the resistances of this star ACD as it is in the circuit. Okay. So revised circuit is like this, and C was connected to, you can say, B dash as earlier. Okay. And again D was also connected to a common node, you can say B dash. So this is the revised diagram. For your sake, I have also redrawn this circuit in a light texture, light pen shading, so that it is convenient to you and so that you can interpret what is going through. So this is the same A, C, D, and it is placed like this. And this 3 ohms and 5 ohms are as earlier. This B dash is the common node and it is connected to the other 2 ohm resistance. Okay. So now whenever the current is flowing from A to N, this N node, there will be a current division. So this upper branch and this lower branch will be in parallel. Okay. So NCB dash, this is the B dash. Okay, which is again redrawn here. So this NCB dash and NDB dash are in parallel. So we know how to calculate the parallel circuits and the resistance. This 1 ohm and 5 ohm is 1 by 1 and 1 by 5, and we can calculate the equivalent resistance. Okay, I will not do this thing again and again. This is very small thing, and you, this is minor thing you have studied in your previous classes as well. So we will calculate this parallel, sorry, this 5 ohm and 1 ohm is in series, so it becomes 6 ohms, and this 3 ohm and 2 by 3 ohm are in series, so they get added up, and now these circuits are in parallel. Okay, so we will calculate these parallel values, parallel combination as this. Now the revised circuit is that we know the value of this, as 66 by 29 ohms. These 2 ohm and this 2 ohm are in series, so they gets added up, and so this is the equivalent resistance which we have calculated. Okay, clear? Dipanshu, clear hai?
Yes, sir. Clear है, sir.
ठीक है. Okay, now we will move to another numerical. Uh, so, so this is the numerical which is given here. The star combination of resistances is given. So, question is that convert the given star into delta. Now, if this star delta networks are superimposed, what will be the resistance between A and C? Okay, so here, first of all, since star is given, we convert this star into delta by simple application of formula. I have mentioned you the two formulas RA, RB, RB, RC plus RC, RA upon the desired resistance. Okay, so using this, you can calculate the value of R1, R2, R3 and draw the delta network. Okay, so this is was the first part. So now what we have to do, we have to superimpose these star and delta networks. Okay, so this is superimposed as this. Star is as it is and delta is superimposed on it. So now it is the same sort of situation which we have studied earlier. So now this circuit internal star is again converted into a delta. So on first part also and now again when we convert we will get the similar values of R1, R2 and R3. Okay, so this 223 is having again more 223, this 247 is again 247. Okay, so now these values are in parallel. Okay, so we will calculate this value when the similar values are in parallel, then the resultant becomes half, isn't it? If 2 ohm and 2 ohm are in parallel, then the resultant is the 1 ohm. Okay, so similarly these 247 becomes half and this 318 becomes 159 and so on. Okay, so now these two resistances are in series, and this we have to calculate the resistance, effective resistance between A and C. Okay, so to calculate the effective resistance we should know what combination of resistances are in series and what combination are in parallel. So we can fictitiously connect a battery here. This is the fictitious battery which we are connecting here just to have the feel that which resistances are in series and which are in parallel. So now when the current is flowing here, in the A node there is a current division. Okay, current gets divided. So the current will flow this way, So these two resistance are in series, and their series combination will be in parallel combination with this resistance. So same we have written here, this 111.5 is in parallel combination with the series combination of these two, and we will get the desired 80 ohm resistance. Okay, Anjali, it is clear to you?
Yes, sir.
Okay, now we will do one more numerical to clarify this theorem. So we have to find the current here in the given circuit. So I have explained you earlier as well what is the need of solving all these DC network circuits. Either it can be to calculate the effective resistance, effective current, effective voltage drop or voltage drop across any one resistance, or the whole resistance, or the power consumed. Okay, the numerical can be in any of these form. Okay, so here we have to calculate the current using the star delta transformation. Okay, so here whenever we are required to calculate the current in the network, it means that we have to reduce the current reduce the current circuit in the form of Ohm's law. We have to reduce the current circuit in such a manner so that the Ohm's law can be applied. So in simple language, what does Ohm's law means? It means that if there is a one battery source and one resistance, that's it. So that if V is the voltage, R is the resistance, and we have to calculate the current, then this Ohm's law can be applied. So our aim should be to convert the current circuit in such a manner so that it is transferred in a Ohm's law fashion. Okay, so this is the circuit which is given, and we have to transform star into delta. So A, B, C nodes are given, and it is a star. So we have to convert this star into delta. So again, we can see that sometimes you may get confused that is it a star or not. Okay, so if we connect this node here with the resistance in between, okay, and this resistance here in between, then you can say, okay, yes, it is having the shape of Y or star, then you feel comfortable. Okay, so this is what you have to do. You have to make yourself comfortable with nodes and mesh so that easily it is convertible. So now this ABC star is to converted into a delta. So star into delta conversion says that you have to multiply two resistance at a time and add them up. Okay, so RA RB plus RB RC plus R RA RB and RARC. Okay, so this is done, and denominator is to be placed. Okay, so if we are, again you remember the formula. For example, if this is the A here, this is okay. Let me make it here so that it is more comfortable to you. So this is B and this is C. So now the resistance after delta conversion, this RAB is here. Okay. So when RAB is here, we divide the resistance which is connected to opposite node. So this is the C node. So we have to divide the formula by RC. Okay. So numerator is always clear that it will remain RARB plus RBRC plus RARC. Okay. It will remain same. Question is just that what we have to divide. So if we are going to divide by RC, we will get this RAB value. Okay, here you can, okay. Similarly, if we divide by this RA value, the resistance will be placed here between B and C. And similarly, if we divide by the RB value, okay, or this 6 ohm resistance, then we will get the corresponding resistance here. Okay, so it is nothing but the application of the direct application of the formula. So we get this delta, and this delta is just picked and placed in the circuit which is given earlier. Okay, but only what is the difference is that now star is converted into delta, and each delta branch will have the resistance which is shown here. Okay, so now this is the revised circuit. Now if we focus on these two nodes, we can see that if the current is flowing from here and it is coming here, so these two are in parallel. Similarly, if current is traveling here and coming from here, it gets added in this node when we KCL is applied. Okay, so what does this mean? That these 2 ohm, these are in parallel and these two resistances are in parallel. So we will add these resistances and get the desired results. Okay, so now these two resistances are in series, which is calculated and placed here. Okay, now these resistance and this resistance are in parallel, so again that parallel is solved and placed here. So now this resistance and this 4 ohm resistance, which is given in series with the 10 volts battery, are in, these two are in series, so they gets added up. So when these are added, it is somewhere 9.4 something. So now our circuit is ready to be, so that the Ohm's law can be applied. So now the current is equal to voltage upon the equivalent resistance which we have calculated. So we can apply this. Okay. Is this clear to everyone?
Yes, sir.